One day, when humanity no longer fits on Earth, where will our first stop be? Or that empty sphere we see when we look at the night sky, the moon? It had been there for billions of years. It was there when dinosaurs reigned, when the first humans discovered fire, and when empires rose and fell. And it has been watching us ever since. It watched us like a faithful, silent, and unreachable guardian. But until today, the moon was merely an object of observation for humanity, or at most, like a book hastily planted with a flag 50 years ago, then abandoned and relegated to a dusty shelf. But today, the Artemis II crew returned to Earth. They didn't just bring back rocks, they brought back billions of dollars worth of data, the user manual for our new home on the moon. The question is no longer, can we go to the moon? The question is, how will we survive on the moon? Today at Axioryn, we will plan and explore together how life on the moon would be possible, if it is. We will witness everything from the power plants of our first cities to the chemistry of building houses from lunar dust and the separation of our species from Earth. Buckle up, the real journey is about to begin. If you want a colony somewhere, what do you think the first thing you need to do is regenerate? If you're left breathing or eating, you're doomed. Our first priority must be energy. On Earth, solar energy is an option, but on the moon, it's a matter of survival. A day on the moon lasts approximately 28 Earth days. This means 14 days of pitch black darkness and freezing nights. So how will we keep warm for 14 days? With batteries? That's impossible because no battery technology is currently sufficient for that. So what could the solution be? Engineers have their eyes set on the eternal light hills at the moon's south pole. These are rare spots that receive sunlight for almost 90% of the year due to the moon's axial tilt. This should be the center of our colony. We will build a giant solar panel farm there. But that's not enough. NASA's kilopower system, consisting of small nuclear fission reactors, will be our real power source during those freezing 14-day nights. If we can't unlock the energy, we only have a few hours of life left on the moon. Let's think logically together. The cost of transporting 1 liter of water from Earth to the moon is approximately $50,000. This is not sustainable for a colony. But high-resolution laser data from Artemis II has revealed that deep within the pitch-black Shackleton Crater at the South Pole, billions of tons of water ice exist. This ice isn't just for drinking. This ice is a cornerstone of the space economy. When we decompose water into hydrogen and oxygen through electrolysis, we get two things: air to breathe and fuel to power our rockets. The moon is no longer just a satellite. It's a strategic deep space refueling station in the middle of the ocean for ships heading to Mars and Jupiter's moons. Our ships, having escaped Earth's immense gravity with empty tanks, will stop on the moon for refueling and nutritional supplementation. Perhaps the moon will be the first stop on their way to colonies on other worlds. Let's look at the issue of shelter now. Transporting cement, iron, or bricks from Earth would be logistical suicide. Therefore, the solution lies on the moon itself, regolith. So, that famous moon dust, as hard as those sharp microscopic knives and sticking everywhere. Engineers are working on a method we call in situ resource utilization. Giant 3D printing robots will land on the lunar surface and collect this dust. They will then harden this dust by cooking it with solar-powered lasers or microwave systems. We call this sintering. Before we even get there, our robots will build thick-walled, radiation-resistant shelters from the moon's own dust to protect us. We won't actually be living on the moon. We'll be wearing the moon's soil like a shield. How will we meet our food needs? Transporting canned goods from around the world? No, that wouldn't be a solution. We must produce our own food on the moon. However, lunar soil is toxic and has no nutritional value. Scientists are focusing on hydroponics or water-based agriculture and aeroponics, air-based farming systems. In closed-loop systems, we'll be growing plants with artificial LED lights in a cycle where we'll even filter our urine and use it as water. Mini greenhouses tested on the Artemis II mission have shown that plants like tomatoes, lettuce, and potatoes can grow even in low gravity, but it will never taste like it does on Earth. For lunar colonists, eating a fresh apple will probably be the greatest luxury and reward on the moon. Now let's look at the main point from a medical perspective. Our real enemy is not technology, but our own biology. The human body has evolved for 4 billion years under 1 g of gravity, resisting the relentless weight of the Earth. Gravity on the moon is only 1/6 of Earth's. While that sounds fun, like floating in the air, it's a very troublesome situation in the long run. Your muscles will atrophy from lack of work, and your bones will lose calcium, becoming brittle like glass. Even more interestingly, because gravity is low, the fluids in your body rush upwards towards your head. This leads to increased intracranial pressure and gradually to vision loss. A doctor living on the moon would likely have less the task of healing wounds and more the need to stop microgravity from slowly tearing your body apart. Perhaps we'll even have to sleep in centrifuge beds, giving our bodies an artificial gravity dose every night. Why do we endure all this hardship? Just curiosity? No, the moon actually possesses a treasure that could fundamentally solve Earth's energy problem: helium-3. This isotope is almost non-existent on Earth, but millions of tons exist on the moon's surface. Helium-3 is the perfect fuel for nuclear fusion, the clean energy of the future. Just one space shuttle load of helium-3 could power the entire United States for a year. The moon is no longer just a satellite. It is the fuel depot for the next industrial revolution. That's why there's a quiet moon race going on between America, China, and private companies. Whoever settles there first will be the energy empire of the next millennium. But perhaps the least discussed danger is psychological. Living on the moon would be a huge test for the human mind. Constantly living in enclosed spaces, being far from Earth, and seeing no signs of life around could put serious psychological pressure on a person. Let's say we manage to solve all the problems for the entire month. Another question we should ask: when we settle on the moon, will we still remain Earthlings? Imagine the first baby born on the moon, a child who has never heard the sound of the wind, felt the rain on their skin, or breathed a breath of fresh air. For that child, the world will be just a distant bright blue sphere hanging in the sky, getting smaller each day. Remember Plutarch's famous Theseus's Ark paradox. If all the parts of a ship are replaced over time, is it still the same ship? If our entire environment, the soilless crops we eat, and the artificial air we breathe are all from the moon, how will our definition of human change? A few generations from now, a species will emerge that is taller, has a different bone structure, and will never return to Earth's heavy gravity. Homo Lunaris. Perhaps, for the first time in billions of years, evolution is turning its course outside of Earth. In conclusion, the moon is not just a satellite for us. It is a gigantic mirror. When we look at it, we see not only craters and dust clouds, but also the potential of the human spirit pushing its own limits. Settling on the moon may be the biggest risk, the most costly gamble humanity has ever taken. But we have always been a species ready to roll the dice. So, will we really live on the moon one day? If one day our grandchildren will travel among the stars, the first stop on that journey will be the moon. As Axioryn, we are silent witnesses to this great transformation. Remember, the sky is no longer a limit, it is simply a new beginning. Thank you for staying with us on this cosmic journey. If you would ever dare to go to the moon and never return, share your reasons with us in the comments. Don't forget to subscribe and stay curious. See you in the next episode.